Good morning, herzlich willkommen. Soyez les bienvenus. Thank you for joining. It is 11 a.m. in Brussels and Berlin, and we are live on Zoom and YouTube. The German National Academy of Sciences, Leopoldina, and the German Research Foundation DFG welcome you to the International Virtual Conference, Genome Editing in Europe, New Agenda or New Disputes, on the occasion of the German Presidency of the European Union Council. My name is Lucian Brujan, and I work with the Leopoldina's International Relations Department, and I will be your host for the two first webinars. This conference takes place as a series of, in total, 5 webinars, today and tomorrow. Warm greetings to our conference panelists, outstanding experts in their fields, joining us from Germany, Belgium, the Netherlands, Argentina, the US, Japan, Finland, Switzerland, Canada, and Australia. Thank you so much for accepting our invitation. Greetings to the almost 500 attendees connected live across the globe and throughout the time zones from almost 40 countries. Before we get started, just some brief technical remarks. If you wish to ask a question, please use the question and answers feature in Zoom, the Q&A. You will find it down in your screen on the control board, and please send us your questions. We and a team of people who are in the background and are taking care that everything works smoothly. We will collect all your questions, summarize them, and feed them into the panels. In each panel, there will be place for questions and answers. If you want a question to be assigned to a specific panelist, just kindly ask to indicate the name. Feel free to share your tweets and postings on this conference using the hashtags Genome Editing, DFG, and Leopoldina. We now open the conference with 3 messages, and I welcome Professor Gerald Haug, President of the Leopoldina. Gerald Haug is a paleoclimatologist and geologist, and he's director of the Max Planck Institute for Chemistry in Mainz in Germany, and also professor for climate geochemistry at the Swiss Federal Institute of Technology, ETH in Zurich, Switzerland. Professor Haug, you have the screen.
Thank you, Lucia. Dear Katja Becker, dear Mrs. von Krambrun-Taubadel, dear Mr. Burcher, dear Mr. Franken, dear Mrs. Jülicher, ladies and gentlemen, representatives from policymaking, science, civil society, and business. I warmly welcome you to this conference organized by the German Research Foundation, the DFG, and the German National Academy of Sciences, Leopoldina. Thank you for joining us today and tomorrow from across the globe. My sincere gratitude goes to the experts from 10 countries for their willingness to share their expertise with us and engage in this undertaking. Genetically modified organisms, GMOs, and genetic engineering in plant breeding are an obvious hot topic. Often the public debate, however, lacks differentiation, and we end up in a divided landscape. This is where our conference steps in. We want to insert unbiased and factual knowledge in the debate in the spirit of co-designing public policies. We want to look forward into the future and to explore openly and inclusively all options on the table, not just evidence, but also analysis and dialogue with all relevant stakeholders. This is what we consider scientific advice. Ladies and gentlemen, the precautionary principle enables decision makers to adopt precautionary measures when scientific evidence is somewhat uncertain and the stakes are high. It is also our approach to new technologies in Europe and frames the answers to 4 important questions. How do we want to deal with new technologies? How do we weigh up benefits and uncertainties of such technologies? How do we design a regulatory frame which minimizes risks? How do we use empirical knowledge to amend, tighten, or relax regulation? More than 2 decades, there have been so many different interpretations of the precautionary principle that we have to de facto a paralyzed debate, call it a non-debate. Science and practice now have access to revolutionary technologies which question most of our traditional approaches in regulating genetic engineering. These are far more precise and cost-efficient than any known before. These are the so-called genome editing tools. What is the consequence? It has become urgent to find the proper regulation for the application of their products. After all, how can we regulate technologies whose products may be indistinguishable from natural variations? Should the outcome of technology be the focus of regulation rather than the technology itself? And what about the implications on plant breeding? The relevance of efficient breeding for agriculture is undisputed. Agriculture is one of the EU's heavyweight policy areas and common agriculture policy. Just look at the numbers. In 2018, the EU has spent 37% of its budget on farming, 58 billion euros. Even after a planned decrease after 2021, still it is an impressive amount if we compare it, for example, with the Horizon Europe budget. Food production both faces and causes enormous challenges. It is both threatened by climate change and it accelerates global warming. At the same time, we see an unprecedented decline of biodiversity in the agricultural landscape. On this latter aspect, next month, Leopoldina will release recommendations for the improvement of this critical situation. We need a change here, and we need it now. The European Commission recognizes the importance of these problems and addressed it in the Farm to Fork strategy, which, I quote, lays at the heart of the European Green Deal. We strongly welcome the European Green Deal under the leadership of Commission President Ursula von der Leyen and hope to see the first results soon. Ladies and gentlemen, today we discuss the transformation of the food production system. Which role can GMOs in genome editing plants play for a sustainable agriculture? How should we assess the socio-economic and environmental concerns? How should we tie up the loose ends? Tomorrow, we will widen our view and take on a global perspective. We will see how countries that are important exporters of agricultural products on the world market deal with new breeding technologies. We will see where the European Union stands globally. Finally, dear Katja Becker, my sincere appreciation to you personally and to the DFG for this fruitful cooperation. Many thanks to the Leopoldina-DFG organizing team as well for this endeavor. I wish you all an insightful and targeted debate, even under those special circumstances, which is asking for much flexibility and creativity. Thank you and stay healthy.
Thank you, Professor Haug. Thank you very much. I welcome the next speaker, Professor Katja Becker, President of the German Research Foundation, the DFG. Katja Becker is a physician and biochemist holding the chair of biochemistry and molecular biology at the University of Gießen in Germany. Professor Becker, the screen is yours, please.
Yeah, thank you very much. Dear Professor Haug, dear Dr. Franken, Director General Bircher, Director Jülicher, members of the European Parliament, colleagues, friends, and distinguished guests. It is such a pleasure to welcome all of you, also on behalf of the German Research Foundation, to this 2 days conference on the regulatory framework of genome editing on a European level, as well as the related scientific debates. Leopoldina and DFG, Gerald Haug just mentioned this, share really a long-standing tradition of collaboration in many areas of scientific policy advice. And this conference is the ideal way to continue this beautiful tradition. I wish to express my sincerest gratitude to Professor Haug and the team from the Leopoldina for co-hosting this meeting. It is my greatest hope that researchers and policymakers are going to use the next 48 hours to share perspectives and exchange opinions, and that this exchange will enrich, indeed, the public debate. Listen to the science. It is very fortunate that this slogan has gained momentum with respect to the unprecedented crisis that we are facing, from the ongoing pandemic to climate change to biodiversity loss. More and more people choose to actively support policies and actions that contribute to protecting the climate and the natural environment, for example. Research on climate change and biodiversity has played a decisive role in this context and is increasingly gaining public recognition. However, research on agriculture and food security does not enjoy the same level of public improvement. Agricultural scientists and plant geneticists often experience distrust, especially if their findings appear to deviate from long-held beliefs. This may be linked to the widespread narrative telling us that we can make agriculture environment-friendly and solve the problem of hunger and malnutrition by simply employing the romantic ideal of agriculture in pre-industrial times. That this produce less by using extensive production methods. This belief is commonly held in Europe and beyond. All you need to do is to add a bit of urban gardening to the image of the 19th century. If you choose to listen to science, you will find that this is not going to work, unfortunately. If we want to realize progress and tackle the challenges agriculture is facing globally, we will need something more sophisticated than a degrowth strategy. A modern plant breeding approach will have to play a key role in this context. The field of agroecology also has to offer a lot. Cover crops, no-till farming, and intercropping all have their merits and are increasingly incorporated into so-called conventional agriculture to realize intensification in a really sustainable manner. What we need to allow for a well-informed agricultural policy, as the EC is striving for with its farm-to-fork strategy, is a comprehensive assessment of such approaches using criteria that must include not only crop yield, but also nutritional value and environmental impact. All aspects of sustainability, in other words. This conference we are looking forward to aims to contribute to this discussion. In order to inform regulatory approaches, we are going to explore what new breeding technologies have to offer, as well as possible unintended side effects. The adverse impacts of the climate crisis are increasingly adding to the problems that agriculture is facing. Climate change does not only bring about droughts and detrimental heat, it also promotes the spread of all sorts of devastating pathogens. Over the next few decades, we will have to produce significantly more food and other plant-based products globally in order to contribute to meeting the Sustainable Development Goals, despite all of these challenges. Moreover, we will have to achieve this on a less land and using significantly smaller amounts of fertilizers and pesticides. So what can new breeding technologies contribute, and what are the issues? There are three different levels that we will have to disentangle to allow for fruitful discussions. First, are crops originating from NBTs safe and healthy for consumers? Second, what are the environmental risks and maybe benefits? And third, what about their socio-economic implications? All of these three levels must be taken into account, making the best possible use of the diversity of scientific, political, and geographical backgrounds represented at this conference. NBTs are certainly not a silver bullet that will solve all the problems agriculture is facing. However, banning the use of modern technology will make it even harder to master the challenges ahead. The ways in which NBTs should be regulated is a matter for society as a whole, rather than just the academic world. Let us therefore strive for an even better informed public discussion, because the issues at stake are urgent and challenging indeed. I hope that these very important topics will be transformed into intellectually stimulating questions over the next 2 days. Thank you all for your contribution, and may we all experience very insightful discussions. Thank you.
Thank you so much, Professor Becker, for your words. I now welcome Dr. Lorenz Franken on behalf of the German Federal Ministry of Food and Agriculture, Minister Julia Klöckner, who cannot join us live today. Lorenz Franken is an international expert on bio and genetic engineering, and he's currently director of the Department Consumer Health Protection, Nutrition and Product Safety in the Federal Ministry. He has been working very closely with Minister Klöckner and in several leading positions within the ministry since 2002. Dear Dr. Franken, you have the screen, please.
Dear Ms. Becker, dear Mr. Haug, colleagues, ladies and gentlemen, please let me first convey my minister's regards. Indeed, your work and the exchange with you are particularly important to her. Why is that? Well, the Federal Ministry of Food and Agriculture is responsible for people's life issues: nutrition, safe food, and agriculture. With these issues in particular, today we are faced with a challenge that we have become mired in ideological discussions in many areas. And many people have become entrenched in their views and have forgotten how to conduct a dialogue. But this approach is not getting us anywhere. That is why we need a willingness to talk to one another and to seek compromises. With today's event, you, the scientific community, are actively addressing current genetic engineering issues. New impulses from science, such as your current statement on genome-edited plants, are indispensable for social and political discourse. What expectations do we have of genome editing today? Well, it is remarkable indeed that there are different expectations not only between, but also within various social groups. And it is no secret that even within the German government itself, we are still having an intensive discussion about a responsible approach towards this particular topic. The widely disparate opinions are important for political discourse and have their value within democracy. Politics, business, and science, we must all take into account people's diverse opinions. But while broad discussions take time, advances in breeding research are rapid. For decades, random mutations have been used for breeding according to the principle of trial and error. While this often resembles searching for a needle in a haystack, genome editing allows us to process genetic material in a much more targeted way. Using new genomic techniques, we can indeed speed up breeding processes massively. According to your recommendation, already mentioned, time savings of up to 50 years are possible, depending on the specific technique. We could use this time gain wisely in fields where the need for innovation is particularly high. As already mentioned, climate change impacts such as drought, food shortages, or the loss of biodiversity call for urgent action to be taken. As I said before, the impetus and work of science and industry is important, always bearing in mind that the results of research have to be fed back into society, providing a benefit to all. So how can we realize the potential of new technologies most effectively? At present, genome-edited plants are regulated as GMOs in the European Union. The current legal framework is more than 20 years old. Actually, some of its core part go even back to the 90s. I personally can remember very well the entering into force of the directive on the deliberate release, because that was the time when I finished my doctoral thesis about 20 years ago. And evidently, since then, many things have changed. For instance, and most unfortunately, my hair has turned gray. Well, some might wonder, how is that related to today's discussion? Actually, I do not want to compare the state of EU biotech law to my hair color. Anyway, I think we should very, very thoroughly check whether EU biotech law still properly reflects the interplay between the precautionary principle and the need for innovation. In my opinion, the precautionary principle is a valuable asset. But we must also take into account the current state of science when applying it. With regard to new breeding techniques, many scientists argue that the risk assessment of a modified plant depends not on the tool used, but on the specific characteristics of the organism. Or in other words, new legislation should look at the product, not the process. On the other hand, there are voices who consider the current regulation as interpreted by the European Court of Justice to be appropriate and sufficient. From this point of view, efforts should be focused merely on the tracing system for new breeding techniques. Between these opposing poles, the Commission is currently preparing its study on new breeding technologies, a very challenging and nevertheless exciting task. Congratulations, Ms. Jülicher. The study will be presented next spring. I am looking forward to its outcomes and the Commission's suggestions, and I think you all are too. We as a society have the responsibility to negotiate how we want to use new breeding techniques, and I think we should start negotiating today. That is why I have a few questions for you. First, as scientists, what specific benefits do you believe genetic engineering can provide to society as a whole? Secondly, in retrospect, we must ask ourselves whether genetic engineering has so far met the expectations placed in it. Do you see improvement in this field? Thirdly, do you recognize any uncertainties that we must counter with the precautionary approach, also to counter people's worries? And ultimately, as part of the scientific community, how do you see your role in the discourse? I am convinced that in view of the global challenges, it is our responsibility as a society to objectively analyze how we want to use new technologies. We cannot afford to ignore new technologies. We should use them on our terms for a sustainable and efficient agriculture and food industry. Finally, I wish you a successful and very fruitful event, and thank you very much for your kind attention.
Thank you very much, Dr. Franken. Many thanks to the three high-level speakers for opening this conference and for your encouraging messages. We take inspiration and bonne chance, as you say it in French, from your messages for the next 2 days. Because we are a bit late, you know, we are in Germany, we stick to the schedule. We proceed with the first session entitled Scientific Advice on Rethinking EU's GMOs Regulatory Framework, which will be moderated by Professor Justus Wesseler. Justus Wesseler holds the chair in agricultural economics and rural policy at the Wageningen University and Research in the Netherlands, working on bioeconomy and policies. And I welcome also the two panelists in the session, Professor Martin Quine and Professor Hans-Georg Dederer. Martin Quine is Professor of International Food Economics and Rural Development at the University of Göttingen in Germany. And Hans-Georg Dederer holds the chair of Constitutional and Administrative Law, Public International Law, European and International Economic Law at the University of Passau. Both panelists were part of the Leopoldina Working Group on Risk Assessment and Regulation of Genome-Edited Plants. And That is the group that co-authored together with experts nominated by the DFG and by other German Science Academies, the statement towards a scientifically justified, differentiated regulation of genome-edited plants in the European Union. Justus Wesseler, I give the screen to you.
Yes, thank you. Dear Professor Haug, Professor Becker, Dr. Franken, Mr. Bujan, representatives from the European Commission, European Parliament, scientists, policymakers, stakeholders, colleagues, friends that are joining us today. We will discuss a very important issue. The study by the Leopoldina and DFG has already been mentioned. In that study, important aspects of new plant breeding technologies for societal benefits have been raised. There's also been raised the issue that the benefits might be more difficult to achieve based on the current regulatory system that we observe in the European Union. Now, in this session, we will reflect on some of these aspects. We have two renowned speakers. They have been already introduced. They will present their views. We will have the two presentations one by one.
There seems to be a problem with Justus. Do you copy us? If not, I propose to... Justus, are you online? We are in the digital age. Yes, you were just... Okay, please, go on.
I don't know how much you could follow what I have said and where I did stop, because I was interrupted and don't know exactly what happened. But I give the floor to Professor Keim to start with this presentation. Please.
Thank you, Justus. I'll share my screen. And I do have 12 minutes to explain why GMOs and other new plant breeding technologies can contribute to sustainable development and why the European regulatory approach is inefficient and not science-based. So let me start right away by giving you a brief insight into the challenges for food and agriculture, not only from a European perspective, but from a somewhat global perspective. We cannot ignore the fact that hunger and malnutrition is still widespread. Around 25% of the world population do not have access to sufficient calories and nutrients. There's still widespread poverty and vulnerability to poverty, and this is very closely linked, often the same types of persons. But it's also important to know that most of the world's poor and undernourished persons are actually small-scale farmers in developing countries. So they depend on agriculture not only as a source of food, but for their livelihoods. That's the situation as it is. If we look into the future, there will be further demand growth for food and other agricultural products, including for the bioeconomy. And this is happening at a time when we are more and more aware of the planetary boundaries. Of course, we have to clearly see that food and agriculture have huge environmental and climate footprints. These lead to environmental change, climate change, biodiversity loss. And these are not only externalities, but they're negative feedbacks. We know that climate change is already and will further affect agricultural production negatively, and especially so in the tropical and subtropical regions where many of the poor and undernourished people live. So there is the risk and the danger of rising poverty, rising malnutrition if we don't act in a more sustainable way quickly. There's widespread consensus that to make food systems more sustainable, we need major types of transformations. And there are no quick fixes. There are no isolated solutions. We certainly have to act in various ways and following various steps at different levels. It would be naive to expect or believe that agricultural technology or plant breeding could solve all these problems. but it would also be irresponsible not to see that science and technology, and plant breeding in particular, has at least quite a bit to contribute to many of these different things that we need to urgently address. So let me zoom into plant breeding, and here you see a list of some of the different methods that have been developed and used over the last 12,000 years since the beginning of agriculture. You see, as we move further down in this list, we're getting to more and more precise and efficient and quick breeding types of technologies and methods. And in any other field of science and technology, such spectacular progress would be very welcome. Take medicine, take mobility, take energy. Not so obviously in food and agriculture. There we do have different standards from public perceptions. And we are seeing that there has been in the framing of the public debate an artificial divide. There, everything above this dotted line is now called conventional breeding. Everything below is called genetic engineering and GMOs. Now, it's not only about the labels we give something, it's about conventional breeding is widely perceived as natural and safe, and GMOs are widely perceived as unnatural and risky. And this is also exactly the current EU regulatory approach that differentiates and asks GMOs for very, very different types of tests and regulations. And this, in spite of the fact that over 30 years of risk research are telling us that GMO crops are safe, they're safe for human consumption and the environment. There are no new or no other types of known risks, and therefore there's also no reason to treat them differently in terms of regulation. This is about environmental and health risks. But of course, one may argue there are other things that matter for sustainability. There are social concerns that many people in the debate attribute to high-tech farming. We are observing increasing use of chemicals. We're seeing less and less diversity in monocultures, increasing farm sizes. Many are concerned about patents on life that may contribute to monopolies. In short, we're seeing what's often termed industrializing or industrialization of food systems. And yes, many of these things are real and they are indeed problematic from different sustainability perspectives. But in the end, we need to be careful where's the real cause, and is it really not too simplistic to assume that all new types of technologies will inevitably aggravate these issues? Or can we perhaps use science and technology and develop it further to address and solve some of these issues? Let's look at the potentials of gene editing. I mean, much of the work of the last years and decades has actually moved into developing crop plants that are more resistant to pests and diseases, or that are more efficient in terms of nitrogen and phosphate. So they can work in terms of reducing agrochemicals. Yes, previously, traditional plant breeding approaches over the last couple of decades have been focused on a relatively small number of different species. But here now with gene editing, we are seeing actually work already in more than 40 different species. So diversity could be brought back. It's something that's working with the seeds that all farmers, including small farmers, are using. Gene editing is relatively cheap and can also be used by small labs, by public organizations. So it could bring back competition and diversity into seed markets if efficiently regulated and managed. And of course, that's a big if. And that's why we are having this conference. Now, let me bring you another example that's showing clearly that it's not the breeding method as such that's creating impacts, but it's the way we're using it, the types of crop traits that we're developing and how they're integrated into agricultural systems. Let's look at some of the evidence we have on the GMOs that currently exist. They have been adopted widely in more than 25 different countries over the last 30 years. Unfortunately, we're only talking about two types of traits, insect resistance and herbicide tolerance, while other traits have been developed. They've not been approved due to overly precautious regulatory approaches. But let's look at these. These are data from a meta-analysis of all the 200 or so different studies that have been carried out. We're seeing, yes, both of these traits, insect resistance and herbicide tolerance, do contribute to higher yields and higher farm profits, but we also see a major difference, namely insect resistance that's contributing to reductions in chemical pesticides, herbicide tolerance, rather to an increase. So can we say that GMOs do contribute to lower pesticide use? No, we can't, but there are certain applications that do and others that don't. So it depends on the trait. There are also other differences. Insect resistance crops are used by all types of farmers, including smallholders in countries such as India, China, South Africa, and so on and so forth. Herbicide tolerance so far is almost exclusively used by large, fully mechanized farms, partly in monocultures that are not sustainable. So there are differences in how things and technologies are being used. And of course, we need serious debate about what types of agriculture we want and need. But blocking useful technologies that can do very different types of things is certainly a very inefficient and non-science-based approach. Let me get a bit more specific on why the EU GMO regulations as they currently stand are problematic. I've already mentioned that singling out transgenic and gene-edited crops as inherently more risky than conventional crops ignores the state of science and research. But this is also further fueling public fears and misunderstandings. Policymakers often say, well, we don't want to approve them because the public is concerned. But well, with this regulatory approach, the public certainly must feel more and more concerned. So there's this mutual reinforcement. Well, there are technologies that cannot be used in Europe for farming. And some may argue, but if they're so safe, they will run through all those safety tests. So why can they not be used? Well, it's a very politicized process. And many of you may know, and others may need to know, that since 1998, no single GMO has been approved for commercial cultivation in Europe. So more than 20 years. So it's effectively a ban. The current regulatory approach is a ban on GMOs, but not only on the applications, it obstructs research, of course, because also field trials need to be approved. And if you do applied research, at some point you need to move out into the field in order to test whether something works and is safe, but you can't under the current regulatory conditions. It jeopardizes the international competitiveness in terms of agriculture, in terms of crop research, and the bioeconomy. And also important to know, I mean, young researchers are really disincentivized. I mean, there are many who are considering a career in plant biotech, but they are saying, well, I don't want to work in a field that's treated with so much hostility in the public debate. So they're turning to other fields. But this is Europe. I mean, Europe, however, is rich. And we could say, well, we can afford that. Perhaps nothing too bad happens. But this does have international consequences, and we need to be aware of them. In other parts of the world, gene-edited crops are not considered GMOs. And that can cause really international trade disruptions, because the European Union is an important player, is also an important importer in international agricultural and food trade and germplasm exchange. And everything that has been using gene editing is actually has to be approved and regulated, not only for cultivation, but for import. any gene-edited crop, unless it contains foreign DNA, and most of the gene editing applications so far don't contain any foreign DNA, they cannot be detected. This leads to problems. I mean, what are other countries and regions doing? Either they say, well, we stop trading with the European Union and we move forward with the technology, but that's unlikely to happen for many countries because the EU is an important importer. The second possibility could be, well, we continue trading with the European Union, but we stop using gene editing. So nothing would happen elsewhere in the world as well. Or we continue trading with the EU, but when it comes to gene editing, we are running through that regulation, but that's a possibility that only large companies have, that only the multinationals have, and they will only do it in large commercial crops and trades. So it would lead and does lead to market concentration, and that's exactly what we would like to actually prevent. I am particularly concerned also about the implications that our regulatory approach has for Africa and Asia, because they look a lot into what the European Union is doing, and they need new agriculture technologies for sustainable food security the most urgent. And this is why we need reform of the European regulatory approach. Thank you.
Justus, are you with us?
Yes, I always move in and out when a presentation stops. So, Professor Keim, Martin, thanks a lot for your presentation. We now directly move to the second speaker, Professor Dederer from the University of Passau.
Thank you very much, Mr. Chairman. I would like to share my screen as well, so I'll try to do that. Okay, now you should see the screen, and I will start my presentation, which is a presentation on the scientific recommendations by the German Science Academies and the German Research Foundation. And these recommendations are published in a statement issued by the Leopoldina and the German Academies of Sciences and the German Research Foundation. And the statement is titled, "Towards a Scientifically Justified Differentiated Regulation of Genome-Edited Plants in the EU." That is the title of that publication. What is the background to this publication? This was the ECJ judgment of July 25, 2018, in the case Confédération Paysanne and others. The court was asked to answer certain questions submitted by the French Conseil d'État, and these questions concerned the interpretation of Directive 2001/18, which is also often called the GMO Directive. And in brief, the questions were, first, are mutagenesis organisms genetically modified organisms, GMOs? And second, what is the scope of the mutagenesis exemption? To understand these questions, we have to briefly look into the structure of Directive 2001/18. And this structure actually is fairly easy. There's a front door, and the front door, that is the GMO definition, which means any organism that is covered by the GMO definition is a GMO. That means it passes the front door and is inside regulation. There's also a back door, and that is the exemption clause. And GMOs, which are inside regulation, may escape from regulation by passing through the back door. So there's a front door and a back door, and the back door is defined by certain techniques, and among these techniques is the technique of mutagenesis. So this is why I call this the mutagenesis exemption. The court answered these questions asked by the French Conseil d'État in the following way. Regarding the GMO definition, the front door, the court chose to construct this definition, to construct the front door broadly. meaning that all mutagenesis organisms, all organisms resulting from mutagenesis are GMOs. Past the front door, are inside the regulatory framework for GMOs. By contrast, the court chose to construct the exemption, the backdoor, narrowly. Of course, the exemption applies to mutagenesis exemptions. However, it does not apply to techniques of mutagenesis which have appeared and have been mostly developed since that directive was adopted, and that was on the 12th of March 2001. The court was a little bit more precise as regards these techniques, methods of mutagenesis. This can be derived from the reasoning of the court and the facts of the case. So according to the reasoning of the court and the facts of the case, these are techniques of directed mutagenesis involving the use of genetic engineering. And by way of example, the court refers to these two techniques, oligonucleotide-directed mutagenesis, in short ODM, and site-directed nuclease mutagenesis, in short SDN. And these techniques, ODM and SDN, are those techniques we call genome editing. So what follows from the judgment is that genome-edited organisms, at least ODM and SDN organisms, are GMOs that are regulated, that are not exempted from regulation. And that means all rules on deliberate release, placing on the market, labeling, and traceability of GMOs apply also to ODM and SDN organisms. And this is so irrespective of whether the genetic modification could have occurred naturally or could have been obtained through traditional breeding techniques. And this is what scientists concerned most, that the regulation of organisms depends on the breeding technique. So one organism is covered by regulation, but another organism which possesses exactly the same genetic modification is left unregulated simply because the genetic modification occurred by nature or was obtained through some so-called traditional breeding technique. And this prompted the Leopoldina to establish a working group, and it did so together with the German Academy of Sciences and the German Research Foundation. The Leopoldina established an ad hoc working group on regulation of genome-edited plants, and these were the members of the working group. And as you can get from their affiliation, the members came from highly diverse scientific breeding methods as well. The means to achieve these objectives are either to narrow the front door, that means to narrow the GMO definition, option 1, or to broaden the back door, which lets GMOs escape from regulation, that means to broaden the exemption, option 2. Now let me refer first to option 1, which is the amendment which leads to a narrowing of the GMO definition. And as you can see here, these are least invasive amendments in the end. So the GMO definition should read as follows. GMO is an organism in which the genetic material is altered in the shape of insertion of genetic information into the genome in a way that does not occur naturally by mating and or natural recombination. What is the idea of these minor amendments? Well, the idea is to clarify the original meaning of the definition. The original meaning is that a GMO is not only constituted through the use of certain techniques. What constitutes a GMO within the meaning of the directive is also the result achieved through the use of these techniques. So what matters is not only the use of certain techniques, but also the result of such techniques. And this should be clarified by this new wording, but in the end, it's simply clarifying the original meaning of the GMO definition. It was never considered to be purely process-based, but also to be result-based. The second option is to broaden the exemption clause and the backdoor that is defined by certain techniques, among them mutagenesis, as you already know. And the suggestion is that we leave the definition as it is, but we broaden the backdoor through adding to the list of techniques the following techniques. Targeted molecular techniques, which when applied, effect a genetic modification that may have occurred naturally, in particular, techniques that cause deletions of DNA, exchange individual base pairs, do not cause stable insertion of genetic information, or cause the insertion, inversion, or translocation in the genome of genetic information known to occur or that could occur with high probability in the natural gene pool of the same species or closely related species. My last slide concerns recommendation 2, the adoption of a completely new legal framework, which means a complete revision of the current legal framework. And this is due to the question, what are the sources of risks to human health and the environment? And scientists, I think, agree that the sources of risk are not, or is not, the process of genetic modification, but it's rather the product and its traits and the use of such products, which pose or may pose risks to human health and the environment. Therefore, from a scientific point of view, the new framework should be product-based, which means the regulatory trigger, what triggers regulation, should be the novel trait of an organism. And further, this framework should ensure legal certainty, which means what needs to be implemented is a consultation mechanism, the purpose of which is to clarify the regulatory status of organisms. Are they organisms which possess novel traits and are covered by regulation, or are they organisms which do not possess novel traits, which are then left unregulated? Finally, of course, the framework should be science-based, which means, for example, that any risk assessment should be adapted to traits and their novelty, and the evaluation, and every 5 years, an evaluation of the legal framework should take place. I would like to stop here, and thank you very much for your kind attention.
Yes, thank you very much, too. We had 2 excellent presentations, one addressing the potential benefits from new plant breeding technologies, and the second one addressing possibilities for reforming the current EU legislative frameworks for approval. Now, let me first ask one question, and that is more directed to Professor Keim, as it addresses more the economic issues. Why is it that the European Union approval process is so much generating so much complications, other countries are also regulating GMOs. They may have somewhat different regulatory frameworks, but they also look into this. So what makes Europe then unique? Why is the European regulation creating a problem?
Thanks, Justus. This is an important question. It's the politicized process. We have a regulation in Europe that foresees that, first of all, certain tests have to be run through, and then scientists and experts in EFSA look into this, and they form an opinion. But in the end, it's politicians of the European Commission that have to make a decision. And the politicians from the different member states, they often make decisions not based on what EFSA says and what scientists say, but they make decisions on what they believe is popular in their member countries. And we do unfortunately have that situation that there is widespread skepticism and distrust, and therefore there's evidence that various researchers, including your group in Wageningen, have done showing how different member countries vote depending on what EFSA is saying. And there are certain countries that always vote no, regardless of what the science expertise has said. And that's the politicized process that's much more pronounced in Europe than elsewhere. However, spilling over, I'm traveling a lot in Africa, and the Africans say, well, if Europe doesn't approve all those things, there must be something wrong with it. So we don't move forward. And there are many things that have been tested successfully in Africa and were never approved for exactly those reasons.
Yeah, thank you. Then I have a direct follow-up question to Professor Dederer. If this is so much a politicized process, how confident are you that the proposals that you have laid out may pass the political process?
Well, this is, of course, a very difficult question, and not directly a question to the law, but to politicians in the end. I'm quite aware, of course, that what we would need is an amendment to the current regulatory framework. That means we need an amending directive, and it means that this process must be initiated by the Commission, and that means in the end that the Commission must get convinced that such an amendment is really necessary right now. And but even if the Commission initiated such a process, of course, the legislator in the end is Parliament and the Council, and we need a majority in both organs, in the Council and Parliament. And I think there's quite a lot of work ahead, actually, for the legislator. And so the outcome, of course, is more than open, actually. So no one can really predict. But I think the legislator could actually vote in favor of that very minor amendments we suggested in that scientific statement. And I think it's possible, as you can see right now in the COVID-19 pandemic, that the legislator is able to act very, very quickly. I do not expect the legislator to act within 1 week like the German Parliament did in spring, but I can imagine that within 2 years, actually, such a legislative process could be in the end carried out.
Yes, thank you. And it's good to know that we have at the following sessions representatives from the European Parliament, the Commission, and other stakeholders that take part in this kind of debate. So it will be nice to see what they have to say. But I also like to know whether or not there have been questions raised in the chat room, and what are those questions?
Yes, thank you, Justus. We are going to extend our session with 10 minutes, but we should finish by 10 past 12. So please, if you could respond in a concise way. There are many questions, and I will try to currently coming in one after the other. There are a few questions regarding the relationship between the European Union and other countries, especially Asia and Africa. One question to Professor Klein. Since the EU has banned de facto GM and gene editing technology, this affects obviously the cultivation of such crops in Asia and Africa. those people will be very reluctant to produce such crops because the EU market will reject them or there is no regulation. How do you comment on that? Shortly, if it's possible.
I would fully agree, and there are concrete examples. Virus-resistant papaya that was grown grown in field trials and close to being commercialized in Thailand many years ago, where under the threat from Europe to stop importing any fruits from Thailand, papaya or any other fruits. Made a complete ban, not only on virus-resistant papaya, but for a couple of years on all GMOs. So these things are real, and the European attitudes and regulations do affect countries in the developing world in particular.
Thank you. Just one short second. We have a few questions regarding how new regulation should look like, but more on the way to approach the whole thing. And there are two questions related to the so-called principle of comitology. It seems that we are stuck in comitology, and shouldn't we more focus on the direct involvement of member states, for example, like in the case of approval of new medicines on the level of the European Union?
Professor Dedor perhaps can answer that best.
Well, I think this could be a new option actually, which would deviate actually significantly from the current regulatory framework. I'm not quite sure actually whether we should really follow this approach, which is the approach under drug regulation in Europe, because even that approach, when you talk to those people who are involved in this kind of process, even those are not lucky actually with this kind of process. So I think the centralized procedure, which also exists actually on the European level when it comes to new kind of drugs, the so-called ATMPs, there is what applies is a centralized procedure, also involving comitology. And so I think in the end, the centralized procedure should be kept actually also under any new legislation. I know the comitology procedure is a problem, and that was described by Martin Keim earlier today. The problem is if it's only the national regulatory authorities which decide on marketing of GMOs or genome-edited organisms, then the system is that other member states need to recognize this, and we will have exactly the same problems. And there will be member states who object any such recognition, which will object to any such recognition on the basis of grounds which I think will be often very political grounds, but not really scientific grounds.
Thank you. We have a policy representative here in our panel, so to say, Dr. Franken. How do you look at it, basically giving it back to member states and providing them more freedom to come up with decisions? How does the German government look at it?
Well, I'm somehow reluctant in joining the optimism just raised by Professor Dedor. Just if I try to answer the question from the German point of view, from the German perspective, the German vote related to the marketing approval of GMOs is well known. The German vote usually is the abstention, because we have still a lot of discussion and fundamental discussions on that within the government. Therefore, I'm not sure whether that approach would lead to a different result.
Okay, so that is a very skeptical view on this, perhaps also shared widely in the literature by others. But Dr. Franken, you have raised the issue of what can scientists do within this debate, and can they perhaps be instrumental for changing the current political situation? So may I ask Professor Haug to briefly respond on that, where he can see the possibilities for scientists to play a more political role in this debate.
Well, I can try. I'm obviously not an expert. I'm a climate person. But from the climate environment perspective, I think there will be a need to go for GMOs in the second part of the century, without doubt, to feed that 8 to 9 billion people. I think in general, a science-based approach in any of this discussion, a rational discussion, should be the fundament of decisions. And if this is well transported within policy making into the society from all of us, I think we can come to a new fundament for decision making.
Thank you. I also like to transfer this question to Professor Becker. Should DFG play a more active role in this, using the voice of science to influence policymakers? You are muted, sorry.
Dismute myself. Yes, yeah. Thank you very much for this question. Yes, I think we are already quite actively involved, actually, in the communication with policymakers. But this is certainly an ongoing process, and we certainly continuously have to intensify these communications and this exchange, particularly because the environment around us in Europe, in Germany and in Europe, of course, and in the world is continuously changing. And also because the techniques and the technologies are continuously changing. So it is very important to stay in the contact, in the close contact and the close exchange. And maybe just to add this, I'm actually very happy that as the coronavirus crisis showed here in Germany, policymakers, decision makers, and society and scientists have been in very, very close collaboration and very close dialogue to be able to maneuver through this crisis. And I think it would be wonderful if we could extend this very fruitful experience also to other fields of research.
Okay, that would be then perhaps one of the positive implications of the corona.
One of the few positive ones, yes.
Thank you. Brujan, do we have another question from the audience?
We are running a little bit late, so if
one question.
One more question we will take from the panelists, from Professor Klein, Alexander Maria Klein. Question to Martin Klein. Do you have a comprehensive and weighted list of risks and advantages of different conventional and genetic engineering breeding methods? So the question is about methods and risks. Short answer.
You're muted.
New varieties can come with new types of environmental risks, and these need to be assessed. But by all the scientific insights that we have from the last 30 years, there's no indication whatsoever that the risk is related to the breeding method. So it is related to the outcome, the product of breeding, and not the process. And we are in no way making any statement in terms of get away with all regulation and risk assessment. Of course, we need risk assessments, but we should do that in a science-based way and follow the insights that we got over the last 30 years of research.
Thank you. Justus, if you just allow me, there are many questions in the Q&A channel. If all those presentations will be made available, I just want to say that all what is here is being recorded. The live stream on YouTube is being recorded, and in a matter of a few days, next week, to the end of next week, we will have all the sessions recorded on the DFG official channel, DFG Bewegt, and on the Leopoldina-DFG channel, so on 2 platforms. That's all from my side. I give now the screen to you.
Yes, thank you. So let me summarize what we have discussed so far. We have seen that that these new plant breeding technologies, they offer a number of opportunities that when we look at those new technologies from a national as well as international perspective, then we first observe that there are a lot of international relationships happening with respect to the policy regimes that European Union, but also that other countries apply. So there are substantial spillover effects. And in particular, if we look at the European political and regulatory environment, we observe that the regulatory approach that is used in the European Union seems to result in a number of obstacles for the private sector to invest in these new technologies, so that they may either move to other countries or do not invest in these new technologies at all. And so from that, we have seen there's a claim that there's an important overhaul of the current regulatory system needed. And I really like the approach by Leopoldina-DFG to come up with some concrete steps how this can be done. We have also seen that that might not be easy, that within the policy debate, a proposal may not easily fly through, but I think it's important to have one to start the debate. And I think from that perspective, I like to congratulate Leopoldina and DFG for initiating this debate that we have today and tomorrow. And I really look forward to the other presentations that we will have today and tomorrow, also more from policymakers and other stakeholders involved, how they look at the specific issues, and hopefully that we then in the end will learn from this and move forward in a constructive way, also based on the positive experiences that we have made during the Corona crisis that seems to provide some more opportunities to come to common solutions. So from my side, thanks a lot to all the panelists, as well as to the audience that was listening and providing interesting questions. And now I hand over to Lucien Brujan for some final remarks.
Thank you very much. Just one sentence. Thank you for joining us after a short lunch break. Please join us again. We will have a high-level panel discussion with policymakers from the Commission, the Parliament, and the European Council, and representatives of business and farmers associations and science, which will start at 1 o'clock, so 1 o'clock p.m. Central European Summertime, GMT +2. Thank you very much. That's all for now. Bye-bye.